question is, when should you run two separate regressions? Now, we really need to make sure that we understand what do we mean by this two separate regressions. Two separate regressions on what? Okay. And generally, the way these questions will be phrased is that you are going to have a sample, right? So you'll have a sample. And this sample could be divided into two groups. So this could be a subsample 1, where generally I could say this D, a dummy variable, is equal to 1. Or I could have subsample 0, where this D is equal to 0. And you could have two versions of the world, okay? In one version of the world, you could say the subsample 1 and the subsample 0, I'm going to treat them the same way. So I'm going to look at version A of the world, where I'm going to say my Y is going to equal to some beta 0 plus beta 1 times X plus the epsilon. That's one view of the world. The second view of the world, which is more general, and it allows you to say, I'm going to split that sample into two separate and different subsamples, would be this. Y is equal to gamma 0 plus gamma 1 X plus gamma 2 times D plus gamma 3 times D times X plus V. Note a couple of changes. One, I'm using different notation for the gamma than the beta because they could be different. Okay, these are two very different views of the world. I'm also using different notations for the error terms because they could also be different. Now the question might be, which view of the world do you prefer? Do you prefer A or do you prefer B? And do you have any statistical tests to show whether A is better or B is better? Here's one thing to realize. What is the interpretation of gamma 2? What is the interpretation of gamma 2? Or in other words, a related question is, what is the interpretation of gamma 0? Let's go one step above. What's the interpretation of beta 0? Angelo, what's the interpretation of beta 0?
Sure.
Okay, that's fine. Mara, what's the interpretation of beta 0? It's the intercept, okay? So if you go and look at the regression, that beta 0 is simply the intercept of the whole sample, because you're treating the whole sample as to 1. What is gamma 0? Is the intercept of the group where D is equal to 0. What is gamma 2? Anna, what is gamma 2?
It's the difference in the slopes.
It's the difference in the intercepts between group 0 and group 1. Okay? So gamma 2 is telling you that there is a difference in the intercepts. So gamma 2 is difference in intercepts. Dylan, what is beta 1? How do you interpret beta 1?
It's just the first variable.
Let's go a little bit more from a regression perspective. Yeah.
It's the slope, or how much y will change with an additional unit of
X, exactly. So it's the slope or the expected change of y with an extra unit of x. Okay, that's what that is, right? Mo, what do you think this is? Gamma 1.
Should not also be the slope
It should also be the slope, but let's be a bit more specific. You're right, there should be a slope.
of the subsample where D is 0.
Perfect, right? It should be that slope when the subsample when D is equal to 0. Okay. Jay, what do you think then is gamma 3?
I'm not sure. Sorry.
That's fine. What do you think? Mara, what is that?
Gamma
Yeah. Difference in slopes between the two groups. Okay, so if I want to ask myself from a statistical perspective, do I prefer version A of the world or version B of the world? The answer would have been run an F test. So run an F test where you're saying that gamma 2 is equal to 0 and gamma 3 is also equal to 0. This is your H naught, and your H alternative is otherwise. What will this test tell you? If you fail to reject this test, then yeah. Oh, this screen is frozen. If you fail to reject this test, thanks. If you fail to reject this test, then which is the view of the world that is statistically preferred? A or B? B, of course. Is that right? If you fail to reject this test, that means that these two things are equal to 0. So if you fail to reject, A would be your favorite. Okay? So if you reject H0, you imply that there is a difference. You imply that there is a difference. Failing to reject H0, okay? Failing to reject H0, i.e. gamma 0 is equal to 0, gamma 3 is equal to 0, sorry, gamma 2 is equal to 0, gamma 3 is equal to 0, then you imply that there is no difference. Implies no difference across subsamples. Here's the good news. In most of the exams, you're actually not going to be asked to do an F-test. Your only job is to recognize that which parameters are leading to the difference. So in this case, it's gamma 2 and it's gamma 3 that's leading to your difference. And to show the examiner that you understand that the way that you test those parameters is through an F-test. So let's summarize. The very good question was, when should we run two separate regressions? We need to qualify what separate means. Generally in MG205 world, separate would mean with dummy variables or without dummy variables. Okay. It could also mean, for example, should you include quadratic versions of, for example, experience or anything of that sort, okay? So when you talk about separate, you need to really think about what is your A view of the world and what is your B view of the world, okay? And then you have to realize under what conditions will those two models be the same. So under what conditions will model A and model B be the same? If gamma 2 and gamma 3 are equal to 0, those models will be the same, okay? So model B would collapse into model A, if you like, okay? Or model B is more general, okay? Here's a question you could ask. Hold on one second, Ravi. You said something there. You said model B could collapse to model A. So model A is a special case of model B. So B is more general. And I would say absolutely. And then you can come up and ask me, okay, Ravi, if B is more general, then why don't I just use B all the time? Anyone wants to answer that question? If B is more general, then why don't I use B all the time? Dennis? It might look more complex. So his answer is it look more complex, but we don't care about it. Data will do it for us. So from a complex perspective, it's just regress this and that. It doesn't really make much of a difference. Anshul?
Is it because you don't have enough information on every single variable?
We have to elaborate. What do you mean by, is it enough that you don't have enough information? What information are you talking about?
You will need like a bigger sample for both d equals 0 and d equal 1 to be significant. So more information in that sense.
Okay, you're kind of hinting towards the right things, that you need a bigger sample. The thing is that you're going to have 4 parameters to estimate as opposed to 2 parameters to estimate. That's going to come at a cost, right? Trying to estimate these 4 parameters is going to be costly, okay? So yes, B is more general, right? But you're going to have 4 parameters to estimate as opposed to 2 parameters to estimate. Okay, and the sample size there will matter, for example. Okay, so this would conclude that question of the 2. Yeah, let me take one question.
I don't understand why it's the difference in intercepts and difference in slopes, like gamma 2 and gamma 3.
So you don't understand why gamma 2 is the difference in slopes and why? The best way to do that is to look at this B regression and set D is equal to 1. If you set D is equal to 1, when D is equal to 1, it will simply collapse to y is equal to gamma 0 plus gamma 2 plus gamma 1 plus gamma 3 times x. And you'll see that very clearly, right? So you could see that when d is equal to 0, you are not going to have this, and you're not going to have this. So those are going to be exactly the differences. There's a lecture on dummy variables that I think I'd substitute for Jordi. If you look at that lecture one more time, it's recorded and it's there, and it's in my worked example. I think you will see this. Sure.